Hello everyone, so in today's video I'll be going to explain some of the gate questions in DBMS. So starting with the first question, so the question states that in a relational data model, which one of the following statement is true. So we can see the first option is a relational with only two attributes is always BCNF. If all the attributes of relation are prime attributes, then the relation is BCNF. Third is every relation has at least one non-prime attribute. And fourth, BCNF decompositions preserve functional dependencies. So the correct option is the relations with two attributes always have BCNF. So here is the explanation in detail. So moving on to the next question. So the next question is, consider a relation R A B C D E F with the following three functionalities dependencies. The first is AB is implies C, BC implies D, C implies E. So we have to find out the number of super keys in the relation R is. So here the answer is 8, and AB is the primary candidate key and the number of super keys are 8. So the next question is, consider a relation R A B C D E F with the following three functionalities. AB implies C, BC implies D, and CE implies E. So this is basically the explanation of the previous question only. So here we can see that first we find the key of the relation computer close of attribute. So first we can see AB plus, which is ABCDE, BC plus BCDE, and C plus is CE. So we can see that only one candidate key is possible for relation, which is AB. And to calculate super keys, we have 2 raised to total number of attributes in relation minus total number of attributes in each key, which comes out to be 3. So it is 2 raised to 3, which is 8 keys. So the next question is, a relation RAB in relation dataset has 1200 tuples. The attribute A has integer value ranging from 6 to 20, and the attribute B has integer value ranging from 1 to 20. Assume that the attributes A and B are independent distributed. The estimate number of tuples in the output of sigma A greater than 10 or B equal to 18 is. So here we have used the probability formula. First we have calculated the estimated number of tuplets, which comes out to be 820. So this is the strict relational algebra, duplicate tuplets are not allowed. So to find the number of unique tuplets, we multiply 15 into 20, which is 300. So the total estimate number of tuplets are 41 by 60 into 15 into 20, so the final answer is 205. So the next question is MCQ based question. So here the question is given as the set of function dependencies. So here they have given various dependencies. So first is F is equal to QR belongs to S, R belongs to P, S belongs to Q. Holds on relational schema X is equal to PQRS. Then second is X is not BCNF. Suppose X is decomposed into two schemas Y and Z, where Y is PR and Z is QRS. So there are the two statements given below, and we have to select which of the following is true. The first statement is both Y and Z are in BCNF, and second is decomposition of X and Y and Z. Decomposition of X into Y and Z is dependency preserving and losing. So the options are only second one is true, neither first nor second, only first is true, or both first and second. So the answer is A, second only, and here's the explanation of it. So the next question is, consider a relation table R that is in 3NF but not in BCNF. Which of the following statement is true? So here there are 4 MCQ questions. So we can see that the correct one is the R has a non-trivial functionality dependencies X belongs A, where X is not a super key and A is prime attribute. So moving on to the next question. So it is an MCQ based question. Which of the following functional dependencies hold for relation R, A comma B comma C and S B comma D comma E, where B belongs to A and A belongs to C? The relation R contains 200 tuples and the relation S contains 100 tuples. What is the maximum number of tuples possible in the natural join RS? So the options are 100, 200, 300 and 2000. So to solve this, from the given set of functional dependencies, it can be observed that B is a candidate key of R. So all 200 value of B must be unique in R. So there is no functional dependency given for S. So to get the maximum number of tuplets in output, there can be only two possibilities of S. The first one is all 100 values of B in S are same as, and there is an entry in R that matches with this value. In this case, we get 100 tuples in output. And the second case, all 100 values of B in S are different and these values are present in R also. So in this case also we get 10 tuples. So the correct answer for this is the first option, 100. So next question is, assuming that the suppliers relation above each supplier and each street within a city has a unique name and S name and city forms and a candidate key. No other functionalities dependencies are implemented other than those implemented by primary and candidate key. So here we have to find which of the following is true about the above schema. So the first is the schema is BCNF. The schema is 3NF but not BCMS NF. So third is the schema is 2NF but not 3NF. And fourth is the schema is not 2NF. So the correct option is the schema is the BCNF. So the next question is, which one of the following is not a part of ACID properties of database transaction? So here are given four options: atomicity, consistency, isolation and deadlock freedom. So the correct option is deadlock freedom, because ACID properties are atomicity, consistency, isolation and durability. So instead of durability here they have given deadlock freedom, which is not correct. So the next option is, which is the weakest normal form that the new database satisfied but the old one doesn't? So from the options given, 1NF, 2NF, 3NF, BCNF. So the correct option is 2NF. Here is the explanation of every normal form: 1NF, 2NF, 3NF and BCNF. So the next question is, considering the following transaction involving two bank accounts X and Y, and here is the statement: the constraint that the sum of accounts X and Y should remain constant is that of. The options are atomicity, isolation, consistency and durability. So the correct option here is consistency. So moving on to the next question, consider the relation X, P, Q, R, S, T, U. Which of the following set of functional dependencies, F, PR belongs to ST, PSU belongs to QR? So we have to find out which of the following is trivial functional dependency of in F plus, where F plus is closure of F. So here options given are PR belongs to ST, PR belongs to RT, PS belongs to S and PSU belongs to Q. So here we can see that the correct option is PS belongs to S. So moving on to the next question, given the following two statements, S1, each table with two single value based attributes is 1NF, 2NF, 3NF and BCNF. S2, AB belongs to C, D belongs to E and E belongs to C is a minimal cover for the set of functional dependencies AB belongs to C, D belongs to E, AB belongs to E and E belongs to C. So we have to find out which of the following from following are correct. So first is S1 is true and S2 is false. Both S1 S2 are true. S1 is false, S2 is true. Both S1 S2 are false. So here we can see that the only the first S1 is true. So the option answer is option A first. S1 is true and S2 is false. So moving to the last question, the maximum number of superkeys for a relation schema are E, F, G, H with E as the key is. So here they have given a supercase set of attributes within a relationship such that no two distinct tuplets can have the same values for those attributes. So the possible combinations are E alone, E, E with one additional attribute, EF, EG, EH, E with two additional attributes, EFG, EFH, EGH, E with three additional attributes, EFGH. So the answer, which is like the maximum number of superkeys for relational schema, is 8. Yes, thank you.